We are a student team coming from the University of Southampton. Our name's Futura Aerospace, and our idea is to essentially redesign the control system of current satellites. Futura Aerospace has formed from a need of the space industry. Each satellite that is sent up into space is required to either rotate or move to perform essential functions and objectives to maintain the mission. This has traditionally been done with archaic technology using somewhere upwards of 8 thrusters, and we are currently hoping to finish our prototype to reduce that down to 2 thrusters for complete control. First and foremost, that's a huge saving in mass and volume, which number one saves you in a lot of price, because each kilogram that you send up into space now is around $3,000 per kilogram. Secondly, if you don't want to save that money, you can use it for more important things on the spacecraft, such as further scientific equipment, so your capabilities as a spacecraft will increase.
The initial funding that we have received from EIBC has been extremely helpful to us to start developing our first prototype. We've been able to purchase the first components, very expensive components, as you can imagine, in the space industry, but that has been crucial and has allowed us to approach the European Space Agency. And now we've planned testing with them at their facility, at their state-of-the-art facilities in the Netherlands next July 2024. And by then, we'll have our first working prototype ready for testing.
Until recently, space exploration was led by the governments and the public sector. But now we have space companies that are revolutionizing the exploration and are becoming, data is becoming more available and more resources are going into this industry, which allows for more opportunities to be able to monitor climate and achieve more science objectives. Our system and our vision will be able to improve the accessibility for these companies to do their objectives.
The main difference from the conventional systems is that our, instead of 8 thrusters, we only use 2, with the gimbal mechanisms on it as well. And with the use of the compliant mechanisms, we'd like to reduce the disadvantages, or takes away the disadvantages of using hinges and bearings in space.
The benefits of our system are multiple. First of all, we have estimated a cost reduction of 40% compared to conventional systems. Second of all, we estimate a 30% mass reduction as well compared to conventional systems. And we estimate an increase in reliability due to some of the engineering decisions that we took, as the design is frictionless and there will be reduced parts, so there will be increased reliability.
The creation of the idea and the inspiration from it came from the need in the current space market today. As you can understand, every satellite that gets put into orbit, into space today, requires a certain amount of freedom and movement. They need to be able to move and rotate to be able to perform specific mission objectives and maintain the actual health of the satellite itself. Traditionally, this has been done with very archaic technologies that use upwards of 8 thrusters. We will be able to achieve the same sort of freedom and control of the spacecraft only using 2 thrusters thanks to our thrust vectoring technologies. It's very exciting. We started this idea and it started off as something, let's say, on the smaller end, but once we started to apply and see actually how far our idea could go, it was something very rewarding to us. So being here today at the Champions of Champions is something we hold great value to. The mentorship in itself is probably worth more to us than the actual cash money, purely because having someone with experience and knowledge about how to grow a small business and how to scale up the business is something invaluable, something that we really truly need. However, the cash money is also quite useful towards us, and any money we do get will be funneled straight into the development of our first prototype. No matter how good you believe your engineering capabilities are, without, first of all, the business skills to identify what the market needs, you're not going to be able to design towards those requirements, and then also to actually put that market towards, put that product towards the market is probably more important than the development itself. If no one sees it, no one knows it. If there is no opportunities to be seen, it might as well be no product to begin with. We just won the Big Idea Prize as well as the Audience Prize. Really solidifies for us what we've been doing is really worthwhile, and that there's other people out there that truly believe in our vision and understand what we're trying to put forth to society. So that money is going to go straight reinvested into developing our first prototype, accelerate our timelines, and just increase the amount of capabilities we can test with that first prototype.